Okay, so we'll start here with number 9. Okay, and so number 9 says triangle ABC is graphed on the XY coordinate plane below. Find the midpoint of segment BC. So if you look here, here's segment BC right here. Okay, right here is segment BC. C has what coordinates? Someone want to just say, what coordinates does C have? 3, 1. Okay, and then what about B? What coordinates does B have? All right, 7, 8, yeah. All right, so if we look here, we want to find the midpoint of this segment. Okay, so from 3 to 7, so we're going from an x-coordinate of 3 to an x-coordinate of 7 here. Well, what's halfway between 3 and 7? It's 5, right? If you look here, if I count in 1, I'm at 4 and 6, and if I count in 1 again, I'm both at 5. So 5 is equidistant. It's 2 away from 3. It's also 2 away from 7. So 5 is the mid-x-coordinate. And if you look here, what's the only x-coordinate that's got 5 as its x-coordinate? What's the only point that's got 5 as its x-coordinate? It's B. All right, it's got to be B here. Okay, it's got to be B. An alternative to this, you can also look at the y-coordinates. Look at the y-coordinates. So halfway between 8 and 1, well, this is a little bit trickier to do. Okay, if we count kind of in here, so here's 1, here's 8. So if I count in 1 and 1, now I'm at 7 and 2, in 1 and 1 again, in 1 and 1 again, and you can see I end up like between here and here. So it's halfway between 4 and 5. Halfway between 4 and 5 is 4.5, which is also 9 halves. Okay, so you can do it that way. You can also average the x and y coordinates together. So for example, 3 and 7, if you average that, 3 plus 7, and divide by 2, and you do 8 plus 1, and divide that by 2, that will give you the midpoint as well. 3 plus 7 is 10, divided by 2 is 5. 8 plus 1 is 9, divided by 2 is 9 halves, or 4.5. So you can see there's your answer that way as well. Okay. Debbie also did something really interesting that I didn't think about. Debbie, what did you do to find the midpoint of that side?
I made a perpendicular.
She did a perpendicular bisector, right? A perpendicular bisector can find midpoints. So that's a pretty clever use of our constructions there. So what we can do is put our compass point there on B, do a football construction, or half a football, put the point on C, okay, do the same thing, and then we use our straight edge. We use our straight edge here to draw this line. Okay, you can see that there's where the perpendicular, there's the midpoint of our segment right there. What's the x-coordinate of that? 5, and it's halfway between 4 and 5, so 4.5 or 9 halves. So that's another way to find that midpoint there. Lots of options. Okay? All right, let's scoot it to number 10 here then. All right, number 10 says, given the figure, line M, so here's line M right here, is the perpendicular bisector of AB and CD. Why is AB parallel to CD? Okay, so we have a volunteer here that wants to say what they think the answer is. All right, Alex, what did you say? You said A, so let's read A here. So A says, the perpendicular bisector intersects the two lines, that's true, creating a linear pair with angles AEF and angle BEF. So AEF, BEF, that's a true statement, but does that guarantee that AB is parallel to CD? It does not. Okay, so it's a true statement. Okay, Alex, so it was a true statement. It wasn't wrong, but it's not helping us to answer what we want to say here. We want to say, why is AB parallel to CD? So it's not A. That just tells us a true statement. That's not, helping us here. So let's read here. Letter B. The perpendicular bisector, okay, that's M again, intersects the two lines, creating supplementary same-side interior angles, AEF and CFE. So it's saying that this angle here and this angle here are supplementary. Okay? That could be true because when we have parallel lines, same side interior angles are supplementary, right? That guarantees we have parallel lines there. So it could be B. So let's hold off on that. Let's take a look at the next one here. The perpendicular bisector intersects the two lines, okay, that's true, creating congruent vertical angles, GEA and FEB. So it's saying these two angles are congruent, therefore these two are parallel. No, vertical angles are always congruent, regardless of whether we have parallel lines or not. And lastly, letter D, the perpendicular bisector intersects the two lines, creating congruent segments AE and EB. Well, again, that doesn't, no, yeah, it's B, okay? Because we have same side interior angles congruent, or sorry, not congruent, they're supplementary, that means these two lines must be parallel, right? That's like the reverse of what we were looking at before. And for example, in the warm-up, when I told you lines were parallel, then we said, therefore, alternate interior angles are congruent. Well, here we're kind of going backwards, and we're saying, since these two angles are supplementary, that guarantees AB and CD then must be parallel. Okay, it's like kind of going backwards. Okay, so questions on number 10 there? Does that make sense? All right, number 11. Let's look at this one then. So QT is perpendicular to PS. Okay, and since QT is perpendicular to PS, what kind of angle do they form, Jason? QT is perpendicular to PS, so what kind of angle do they form? Well, the vertical angle is there, yes. But like when something's perpendicular, what type of angle, when they intersect, what kind of angle are they forming? It's a right angle, yes. So here's PS, here's QT, so they make a right angle. Okay, right there. The measure of angle RUS, so RUS, this angle right here is 63 degrees. Okay, so you can label on your paper there, 63 degrees for that angle. Find the measure of angle RUP. So we want to find the measure of this angle right here. Okay, so, Alex?
I said 117 degrees.
You said 117, how'd you get that?
Because since
we have a straight line right here.
yeah.
Okay.
So since one part is 63,
If this piece is 63, how can I find the other piece?
you can just minus 63 by 100.
Yeah, 180 degrees minus 63 gives you 117 degrees. Perfect. That's exactly right. You don't need to bubble in the degree part, but the 1, and the 7 you do want to bubble in. Obviously, for this one, it's, you know, for the practice, you don't have to bubble it in. But you don't have to worry about bubbling in degrees or anything like that. Just the 1, and the 7 spot. Okay? Good job, Alex. Very good.
Thank you.
Next one, and the last one we're going to go over before I have you guys start working on some more here. All right. Column S. Do you have any idea here how to set this up? We want to determine the measure of angle BCD, and we're given some angle relationships here, some angle measurements. Were you able to set an equation up for this or anything like that?
So we just subtract the 2x plus 5 from 4x.
So that's, yes, we can do that. You can subtract that 4x minus 24 minus 2x plus 5, and then what would you do? So you're saying you want to do this, 4x minus 4x minus 24 minus the 2x plus 5, right? You want to subtract the two angles? Like that? Okay, so that will work, but what else? We need to equal something, though. What's it got to equal? We need to solve this equation, so it's got to equal something. Not sure. So you're actually on the right track there. I don't know if you realize that or not, but let's look at it from a perspective of what we talked about earlier in this class. What is this kind of angle called? Since it's on the outside of the triangle, what do we call this kind of angle? Well, it's obtuse. It looks obtuse, yes. But since it's outside the triangle, what do we call it, though? Exterior angle, right? What is the relationship between an exterior angle and the two remote interior angles? So, right, you have to add up the two remote interior angles, and it equals the exterior angle. So we can say 47 plus 2x plus 5 equals 4x minus 24. Now, Colin, whether he realized it or not, okay, he was on the right track there, because if he had said that this was equal to 47, then his would have been right too. So Colin was really close there. I'm sorry, yes. Thank you for saying something there, Brianna. Yes. Okay. So again, the two remote interior angles add up to equal 4x minus 24. Okay, and again, we want to find angle BCD here, this measure. We're going to find the measure of angle BCD. Okay, so let's combine like terms here. I get 2x plus 52 equals 4x minus 24. Okay? So there I combined my terms. I did the 47 plus the 5, gave me 52. And now I have variables on both sides. So, Colin S., why don't you keep, how can we continue solving this equation right here? The one that's right there. What should we do here? I have variables on both sides. So how can I get them together? Subtract, you want me to subtract the 2x or subtract the 4x?
2.
Yeah, I like getting rid of the smaller 1 as well. Okay, so you get 52 equals 4x minus 2x is 2x minus 24. And then what, Colin, what we do next? You got it. Add 24 to both sides. Very good, sir. So we get 76 equals 2x. And then what? Yeah, you got it. Good job. X is 38. So our answer is 38.
No.
No. Good job, Tristan. Very good. Okay. What do we still have to do with this 38? Yeah, substitute it. Plug it back in because we want to find B, C, D. Folks, please, you're going to break my heart tomorrow if I see you get so far and then you give me this in the bubble in. Okay? Please do not do that. It's going to make me really sad. Not that you have to like make me happy or anything like that, but it really does. It like stinks when I see this happen. It really makes me upset because I'm like, man, you guys were so close. You're so close, and all you got to do is just plug that 38 back in for the X. Okay? Because it said find the measure of angle BCD. Don't find X. I mean, you need X, but X is not the answer. It's the angle BCD. So please, on tomorrow's test, when you're doing this problem, if you see a problem like this, which I'm pretty sure you will, okay, if X is 38, plug that back in, and it's 4 times 38 minus 24, okay? So 128 degrees is the answer. Okay, 128. All right. Questions on any of that? All right, so what I want you guys to do then is work on those free response questions. Those are next.